Bismillahirrahmanirrahim. Assalamu alaikum, dear students. I am Mr. Saad Khan, your instructor at Department of Technology, Sarhad University of Science and Information Technology. The course that we are studying is Introduction to Computer Fundamentals with the course code as CS102. Today, we are going to start our lecture number 4, that is Introduction to Programming Languages. Now, coming towards the computers and what is a computer programming, there are a few different terms. We are going to discuss them in detail. First of all, a computer is a programmable machine. This means that it can execute a programmed list of instructions and respond to new instructions that it is given. We have discussed it in our previous lectures of software and software types, that a computer only and only it performs on the basis of the instructions provided to it. It does not have the capability to think on its own self. We have provided it within instructions, and all those instructions, whatever we are giving it, they are converted into binary language. The computer understands them, executes those instructions, and then give us the desired output in the form of our human generated language. So now, computer programming. Computer programming is the process of developing and implementing various set of instructions to enable a computer to do a certain task. The process of developing and implementing various sets of instructions. Now, what do you mean by the word developing and implementing the various sets? In simple words, let's say that we give instructions to a human. For example, if I give an instruction to student A and student B. Now student A is given 5 number of instructions, 1, 2, 3, 4, 5. Student A is going to perform all of those instructions in the sequence manner. Like, first of all, the instruction 1 is going to be executed by student A, then instruction number 2, then 3, then 4, then 5. Same way in computer programming, computer is given instructions and the computer performs and implements those set of instructions sequentially. Now the next term is the programs. Programs, what is a program? They are written to solve problems or perform tasks on a computer. Basically, the word program meaning is that whatever we want to achieve from a computer, we have to write a program. As in simple words, if we want to achieve some mathematical calculations, the square root of 4, the square of 8, all these mathematical calculations need programs, the instructions. We give the computer instructions, the computer performs the calculations on those instructions and give us the desired outputs. So up till now we have studied two basic terms, that is the computer programming, that is the process of developing and implementing various sets of instructions to enable a computer to do a certain task. And the second term is programs that are written to solve some problems or perform that specific task. Any gameplay, any task, whatever we do comes under the program. Now the next term is the programmers. Now, who is a programmer? A programmer is basically a person who is responsible to write a program to instruct the computer in computer's language so that the computer can understand and provide the necessary solutions for that problem. The programmers translate the solutions or tasks into a language the computer can understand. As we write programs, we must keep in mind that computer will only do what we instruct it to do. We have just discussed it in the previous slide, that computer does not have the thinking capability of its own. It is going to only be doing whatever we are going to instruct it. Because of this, we must be very careful and thorough with our instructions. Now, this is just a random slide that introduces the first programmer. Ada Lovelace is the first person to develop an algorithm for a machine in 1842 to 1833. The first computer program, so she is called as the computer programmer, first programmer. She also theorized that the computer one day could play music and chess. A US Department of Defense computer language is named in her honor. So this was the first computer programmer. Now coming towards algorithm, another terminology. Algorithm is a list of instructions, procedures, or formulas used to solve a problem. The word derives from the name of the mathematician Muhammad ibn Musa al-Khwarizmi, a Muslim scientist back in the 700 to 800 century. He designed this. It came from his name. Now, coming towards the main point, what an algorithm is. The list of instructions, procedures, or formulas used to solve a problem. For example, if we are having some sort of a mathematical problem, uh, we need to solve that. So we have to instruct the computer word by word, alphabet by alphabet, number by number, and the problems that are and the procedures or the formula that we are using it inside to solve that specific problem is called as an algorithm. Basically, algorithms are designed for some specific task to achieve some specific goal. For example, if I say that what can be the algorithm for making a tea? The algorithm for making a tea is going to be a few steps, 6 to 7 steps, less or more. For in that we need to have a bowl. In that we can boil water. We need to have sugar. We need to have tea. We need to have milk, and we also need to have some heat source so that we can make the tea. So the list of instructions that are going to be executed in a sequence or the procedure that is going to be done to make a cup of tea will be called as an algorithm. The next terminology is the pseudocode. Now, what is a pseudocode? Pseudocode is a computer programming language that resembles plain English that cannot be compiled or executed but explains a resolution to a problem. Here we are going to discuss this thing as an important thing here, that for example, if a customer comes to a computer programmer and asks him that I'm having some problem and I need a solution for this problem, the programmer in simple layman's words, in simple English type words, will explain the solution to the problem so that the user is able to understand how his problems is going to be solved with the help of a computer. If the programmer starts making things, telling the user in the programming language mode that this is going to be done, this is going to be done, the user is not going to understand it because he is not a programmer. He doesn't know how to instruct a computer. So the programmer is a person who tells the user in simple plain English words. These words cannot be executed or compiled by the computer. They are just to let the user know about that how this particular problem of yours is going to be resolved or solved. Now moving on towards to the next terminology that is an important one, that is the source code. Up till now we have studied what is a program, what is a programmer, algorithm, first computer programmer, computer programming. These are the things that we have discussed till now. And now coming towards the source pseudocode and now the source code. The source code consists of the programmer's programming statements that are created by a programmer with a text editor or a visual programming tool and then saved in a file. Basically, The programming language. Now, let me tell you a simple thing. We have read the terminologies of a programmer. A programmer is a person who is out there to instruct the computer so that the computer can solve a particular problem. Programming language, the language that is used to make the computer understand. For example, if I am to explain something to a student who speaks in Urdu or just in Pashto, so if I am to explain that thing particularly in that language, that user, that student is going to understand it in a well manner. Similarly, a language. Now, what is a language? A language is a way of communication. In humans, we can have so many languages to communicate with each other. In the same way, in the computer, we have the programming languages. Those are the programming languages with the help of which we can communicate with the computer. So the source code is the consist of the programming statements that are created by the programmer. A programmer creates the programming statements that are called as the source code. This source code is saved in the file and then executed, and then the computer gives us the desired output. For example, a programmer using the C language types in a desired sequence of C language statements using a text editor and then saves them as a named file. This file is set to contain the source code. Moving towards the next terminology, that is the flowchart. A flowchart is a formalized graphic representation of a logic sequence, work or manufacturing process, organization chart, or similar formalized structure. The purpose of flowchart is to provide people with a common language or reference point when dealing with a project or process. Flowcharts uses simple geometric symbols and arrows to define the relationships. We have just discussed moments ago in the algorithm that how to make a tea. So it contains 6 to 7 steps. If we are going to put all of these 6 to 7 steps in the form of a diagrammatic representation, that is going to be called as a flowchart. The basic idea and the basic advantage of the flowchart is the user can understand in a well-defined diagrammatical way that from where which instruction is going towards the computer and what is going to be the output of that instruction. So flowchart is basically the diagrammatic representation of how the data is being flowing or the instructions are being given to the computer. Programming languages. Computer programming is always done by means of a programming language. Just like I said in a moments ago that we humans communicate with each other in the form of a language. Language is the source of communication between us humans. For example, if a Chinese person, he does not understand English or any other language. So if you want to communicate with that person, you must have some sort of an interpreter, a common man in between, who is going to translate your language into the Chinese language so that the Chinese person can understand, and whatever he says that the interpreter person, the midman person, should communicate back it to you in your native language. So in computer, when we want to communicate with the computer, we also need to have the programming language. There exist more than 2500 programming languages are in the world. Some of them are known by only their developers. Some of them did not get so much attention or were not that much useful. So they are not that much used as well. Many of them are quite popular as well. We are going to see a list of them as well. Here it is just a diagrammatic a picture which is showing the name of the programming languages, the common and the important one: Perl, PHP, JavaScript, C++, Visual Basic, COBOL, Assembly, Ruby, and many others are there. So coming towards the history of the programming language, the beginning in the 1843, Ada Lovelace wrote a program for the analytical engine. In 1936, Alonzo Church introduced calculus, and Turing came up with the concept of a Turing machine. and 1947 with the concept of stored program computer, John von Neumann. And then 1955, the first programming language that came was the Fortran, then Algol, then COBOL, then BASIC in 1964. After that, 1972, the C language was developed. 1978, SQL was developed. 80, C++, 87, Perl. 1991, Python and Java. 1993, Ruby. And 95, PHP and JavaScript. And up till now on, there are so many more languages that do exist. For example, for the mobile operating system, Android development programming language, JavaScript language that is being used. For website development, we have PHPs and other cross-platform applications. For iOS applications, Apple's mobile operating system, Swift programming language has been developed and is being used. So there are many other programming languages out there now. This is the first generation, second generation, third generation, and fourth generation. This is just a reference diagram that first generation computers with when we were having vacuum tubes, second generation when we were having transistors, and third generation ICs, and the fourth generation when we were having the microprocessor chips. Just a reference diagram showing that when which programming language was developed and in the which area. So coming towards the generations of the programming languages. The first generation computer programming language was and still is machine language, or the level of instructions and the data that the processor is actually given to work on. We humans understand so many languages, but computer understands only one language, that is the machine language. I have told you in the starting lectures that machine language is the language of 0 and 1. The combination of zeros and ones make a machine code. So computer only understands that is the 0 and 1. 0 means the off state, 1 means the on state. In a particular second, nanoseconds of time, thousands of combinations of zeros and ones are being created, and the computer processes it and then gives the desired output. So computer understands only and only the machine language. All of the programming languages, whichever is written, that is we just have seen, that is the C language, the Perl language, any language, all of these languages data is converted into a machine code, machine language, so that the computer can understand it and then it performs the desired instructions. Just like I have given you the example of moments ago regarding that if two persons want to communicate with each other and they don't know each other's language, so they need to have a third person in between who will be doing the translation for the both sides. Similar is the case with the computer. All these programming languages that we use today are converted into the machine language code, and then that machine language code is executed by the computer and gives us the desired output. Coming towards the second generation language is called as the assembler or assembly language. In this language we basically use the simple English like words. It was easy for the programmers because writing a computer program in the form of zeros and ones in machine language is much difficult than writing it in simple English like words. We used to, if we want to add two values, 2 plus 2, so in the assembly language or the second generation language we only need to have 2 add 2. So ADD, an English word, is added in form of a instead of the symbol. Third generation programming language, a high level programming language such as P, L, I, C or Java. A compiler converts the statements of a specific high level programming language into a machine language. Requires a considerable amount of programming knowledge. Now the point is, a compiler converts the statements of a specific programming high level language into, just like I said, that all of the languages are converted from the human language to the computer's binary language, that is the machine language, and then the computer performs the instruction. So compiler is the converter. You can call it as an interpreter or a translator that translates the human's language into computer readable form into the machine language, and then the computer performs the necessary instructions. Fourth generation languages is designed to be closer to natural language than a third generation language. Languages for accessing databases are often described as fourth generation languages. These languages are much more easier. We just need to have a drag and drop options out there. If you want to create an object, we just need to drag and drop it on the screen, and whichever point we want to make some functionality, all of the most of the code is being written and done by the computer itself. So these languages are much more easier for the humans to understand and make the program in these languages. Now coming towards the machine code that we just have discussed, is machine code, also known as the machine language, is the elemental language of a computer, comprising a long sequence of binary digital zeros and ones. That is, this combination of zeros and ones is called as bits. A simple zero is called as a bit, and one is also as bit. But when the combination is so, it is called as bits. Sometimes referred to as machine code or object code, machine language is a collection of binary digits or bits that computer reads and interprets. Machine language is the only language of a computer is capable of understanding. Now this is the most important key point, that the computer only understands the machine language, that is the combination of zeros and ones. This is just an example to show you how in the past, when we used to do some programming in the form of machine code, so in machine code it is quite difficult. If you make a mistake of 1 0 or a 1 at some point or place, the whole instruction set is going to be a different. So it requires a lot of knowledge and practice to write a program in machine language. Coming towards assembly language, sometimes referred to as assembly or ASL language, is a low-level programming language used to interface with computer hardware. Now, the low-level programming language. Basically, we have two types of programming languages. The one is called as the low-level programming languages, and the other is called as the high-level programming language. Low-level programming languages are those languages that are near to the computer. Computer can understand them easily, but they are difficult for the user to program in the low-level languages. Whereas high-level languages are those types of languages that are nearer to the human. Humans, we programmers can make the computer understand or give some instructions in our own daily life language. So it is much easier for us to program. All that high-level language program is converted into a machine language code and then executed. Assembly language uses structured commands as substitutions for numbers, allowing humans to read the code easier than looking at binary. Although easier to read than binary, assembly language is a difficult language and is usually substituted for a higher language such as a C language. Now let me just give you an example. If you want to add 2 and 3. Now the value of 2 in computer's language is machine language is 1 0, and the value of 3 is 1 1. Now if we want to add it, we have to press it 1 0 and then A D D, that is the assembly language instruction, and then 1 1. So the computer is going to understand it that the user wants to add the values 2 plus 3. So this is how assembly language used to work. Now coming toward that, low level languages that I've just discussed have the advantage that they can be written to take advantage of any peculiarities in the architecture of the central processing unit CPU, that we are nearer to the computer's processing unit. So it is extremely efficient. It is a fast program as compared, because there is no interpretation in between, no middleman to make the translation process. Just the example, if the two persons want to communicate, and if they understand both of each other's language, so the communication is going to be an easy one. It's not going to take time. Rather than in case of a high level language, a user is going to be in between, who is going to listen, then translate it for the first person, and then the first person speaks will going to be translated by that user towards the second person. So it is a lengthy process. Thus, a program written in a low-level language can be extremely efficient, making optimum to use of both the computer's memory and the processing time. So the programs written in low-level languages use the less memory and also the less processing time, as the computer can execute them within a few seconds. However, to write a low-level language program, it takes a substantial amount of time, as well as a clear understanding of the inner workings of the processor itself. Therefore, low-level program is typically used only for very small programs or for segments that are highly critical and must run as efficiently as possible. Now, why the low-level program level language programming takes a lot of time is just because of the reason that combinations of zeros and ones instead of using the basic English like words, it's going to take a lot of time out there. And if there is an error occurs, then you have to search for that particular zero or one value inside the thousands of zeros and ones, that whichever was the wrong. So it's going to take a lot of time. High-level language permits faster development of large programs. The final program as executed by the computer is not as efficient, but the savings in the programmer's time generally far outweigh the inefficiencies of the finished product. This is because the cost of writing a program is nearly constant for each line of code regardless of the language. Thus, a high-level language where each line of code translates to one zero machine instructions cost only 1/10 as much in program development as a low-level language, where each line of code represents only a single machine instruction. This is basically just an idea that high-level languages are easier for users. They are efficient for the user, but not for the computer, as computer has to make for understanding purpose, it has to convert it into machine language. So the conversion time is far outweighed, but we have to neglect that conversion time, and we users rely on the high level languages. The first high-level language programming language was used by the Fortran, invented by John Backus of IBM in 1954. 1957 it was released. So this was just a first high-level programming language. Now these are the popularities chart that is being shown in the programming language popularities. That is from January 2013 positions, and position in 2012. The C language rating has improved up, Java language was decreased a bit down, then Objective-C was increased. The many of the languages were not decreased. So this is just a programming languages popularity chart. Compiler, we used this word a few slides ago, that a compiler is a special program that processes statements written in a particular programming language and turns them into a machine language or code that a computer's processor uses. Compiler is basically just that third man who converts the instructions, who makes the both of the user A and the user B understand whatever they are talking and speaking to each other. So compiler is simply a program, special program that is used to convert the high level instructions, that is the user instructions, into a machine language that the computer uses. So after we write a program, our source language statements are compiled into a machine code that are stored in an executable file, and the computer's processor is going to execute them. Scripting languages like Perl and PHP do not need to be compiled. That's not relevant to you, students. So this is just basic a diagram that a high level language code is going towards the compiler, and the compiler is making it in the executable form. Executable form is must be in the machine code. That is because we know that the CPU or processor only works in the binary language, so is executable, and then it is converted. CPU performs the instructions and gives us the program's desired output. Coming towards another terminology that is being important regarding the programming languages, that is the IDE, Integrated Development Environment. An IDE or Integrated Development Environment is a software program that is designed to help programmers and developers build the software. Now, a programmer, a person who is called as a programmer, this IDE is developed for the software programmer person so that he is able to develop a computer program in an easy way. Most of the IDEs include a source code editor, a compiler, build automation tools, and a debugger. So these are the basic four functionalities that an IDE must contain. I'll be showing you the diagrammatic image of what an IDE in the next slide as well. Debugger, a special program used to find errors or bugs in other programs, allows a programmer to stop a program at any point and examine and change the values of variables. For example, if a user, debugger's basic task is a user has forgotten to put a comma, a full stop at the end of a line, or the statement it has written is in a wrong syntax, wrong format. So the debugger's task is to point out the user that this is the mistake that you are making in developing the program. As we have instructed in that IDE programs as well, that whatever instruction is going to be given in that particular format, if the user does not follow that particular format, so the debugger comes in out there and gives the user the desired error. Graphical user interface GUI is a graphical rather than purely textual user interface to computer. Elements of a GUI included text boxes, buttons, pull down menus, lists, and combo boxes. That was just spoken in the high level languages, that we can drag and drop the text boxes, the buttons, and the pull down menus, and etc., so that the user does not need to write the code to form a text box at a particular place, or to make a button at a particular place for some particular functionality. So GUIs, IDEs are quite easier and friendly. Now this is just a dev C++ IDE in which we don't have that GUI options of drag and drop buttons and all that. We have to write each thing in the form of a line of a code. Hash includes studio.h and conio.h. Basically, these are the library files that import the print and scanf functions. So this is just a basic IDE of dev C++. Now this is what a Visual C++ Express Edition shows, in which we have the source files and the left side header files. We can also do the drag and drop buttons. We have many other features as well. The modern IDEs are much more developed than this. I am going to show you the Android developing IDE, how to make an Android application in the class and the upcoming practicals. Software development languages, here we have just an example: C, C++, C Sharp. C and C++ are basic. C language was developed at the first, and it was used for the programming fully. It was high level languages. All of these are C++ language and C Sharp are basically used for the desktop programs, or also the web programs as well. Pascal, Delphi, Visual Basic are other programming languages. Website programming development languages, HTML, it's just not a basically a programming language, it's just a makeout way. XML, extensible markable language, JavaScript, VBScript, PHP, Java, ASP.NET, and others are as well. And another, if you want to go towards the database programming languages, SQL injection series, structured query languages, all of those come in the database programming languages. Important peoples in the programming, this is just a not relevant thing as compared to me, that who created the C programming language and first and all that. Other references of pages are this. If you have any queries and any questions, feel free to ask me in the live lecture class that we are going to conduct today. So before coming to the class, have a look at this lecture, dear students. Let's discuss them all of these things in the class. Thank you. Have a good day. Allah Hafiz.